Dear students, today we are going to start a new topic, that is the indeterminate form. So sometimes we have a limit of the form, limit x tends to a f of x upon g of x as 0 by 0 or infinity by infinity, which cannot be determined. Such limit is called indeterminate, means which cannot determine. If f of x and g of x are functions of x vanishing at x equal to a and having Taylor series expansion in the neighborhood of x equal to a, then limit x tends to a f of x upon g of x equal to f dash of a upon g dash of a. Actually, it is known as L'Hospital's rule. What is this L'Hospital's rule? If limit x tends to a f of x upon g of x gives indeterminate form 0 by 0, then take the derivative of numerator and denominator separately. That is, limit x tends to a f of x upon g of x equal to f dash of a upon g dash of a, provided that letter limit exists. This rule is known as L'Hospital's rule. So what is the meaning of this? If the indeterminate form gives, means that limit gives the indeterminate form 0 by 0, then take the derivative of numerator separately, denominator separately, and put the limits. It is known as L'Hospital's rule. Note that there, if indeterminate form 0 by 0 and infinity by infinity, we can use directly L'Hospital's rule. If limit gives the indeterminate form 0 into infinity or infinity minus infinity, then first simplify that limit such that it becomes or it gives indeterminate form 0 by 0 or infinity by infinity, and then we can use L'Hospital's rule. So where we can use L'Hospital's rule directly? When indeterminate form 0 by 0 or infinity by infinity. In other cases, just like 0 into infinity or infinity minus infinity, you have to convert first 0 by 0 or infinity by infinity. Then only we can use L'Hospital's rule. Sometimes that limits contains the power, and that power contains function of x. And if it gives the indeterminate form 1 raised to infinity, 0 raised to infinity, and infinity raised to 0, then how to evaluate it? First you consider given limit as L, then take log on both sides and convert that indeterminate form into 0 by 0 or infinity by infinity. Then only we can use L'Hospital's rule. Then evaluate it, and finally, once we get an answer for that, then take anti-log, which is your final answer. So what is given here? For this indeterminate, consider L equal to given and take log on both sides. Then we will get any one of the above indeterminate form. Find the value of this. Lastly, take anti-log. So let's consider some examples on it. Student, you note that these standard limits. Limit x tends to 0 sin x by x equal to 1. Limit x tends to 0 tan x by x equal to 1. Limit x tends to 0 sin inverse. It is actually inverse. Sin inverse x upon x equal to 1. Limit x tends to 0 tan inverse x upon x equal to 1. Also limit x tends to 0 1 plus x raised to 1 by x equal to 1. Limit x tends to 0 a raised to x minus 1 upon x equal to log a. Limit e raised to x minus 1 upon x equal to log e, that is 1. Limit x tends to infinity 1 plus 1 by x whole raised to x equal to e, and limit x tends to 0 x raised to n minus a raised to n upon x minus a equal to n a raised to n minus 1. So these are some standard limits which we can use directly. But if we don't know, then also we can find these values by L'Hospital's rule. For example, here consider this one. As x tends to 0, so what is a raised to 0? It is 1. So I am getting here 1 minus 1, that is 0, upon x tends to 0, that is by 0. So this is the indeterminate form 0 by 0. And what rule says? L'Hospital's rule, that is take the derivative of numerator and denominator separately. What is the derivative of a raised to x with respect to x? It is a raised to x into log a minus derivative of 1 is 0 upon derivative of x is 1. Means take the derivative of numerator and denominator separately and put the limit. So what is x tends to 0? Means a raised to 0, it is 1 into log a. So I am getting what is value? That is a log. So you can remember these standard limits or you can evaluate. So consider one example. Evaluate limit x tends to 0 e raised to x minus 1 minus x upon log 1 plus x minus x. So how to evaluate this one? So solution for that, you consider given limit as L, that is the limit x tends to 0 e raised to x minus 1 minus x upon log of 1 plus x minus x. Now just check here limit as x tends to 0. What is e raised to 0? It is a 1, then minus 1 minus 0 if we put x equal to 0. So log 1 minus 0. What is log 1? It is 0. So I am getting here 0 by 0 form. So if 0 by 0 or infinity by infinity, we can use directly L'Hospital's rule. So here it is a 0 by 0 form. So by L'Hospital's rule. So what is L'Hospital's rule? That is take the derivative of numerator and denominator separately. So what is the numerator there? E raised to x minus 1 minus x. So take the derivative of it. It is a e raised to x derivative e raised to x minus 1 derivative 0 minus derivative of x is 1 upon derivative of denominator separately. So log 1 plus x. So derivative is 1 upon 1 plus x minus derivative of x is 1. Now put x tends to 0. So what I am getting roughly you do? E raised to 0, it is a 1 minus 1 upon 1 by 1 plus 0 minus 1. So again I am getting 0 by 0 because here 0 and here it is 1 minus 1, it is 0. Means again 0 by 0 form. So one more time I am getting here 0 by 0 form. Whenever we will get here 0 by 0 or infinity by infinity indeterminate form, use L'Hospital's rule. So again by L'Hospital's rule. So by L'Hospital's rule, what is it? L equal to limit, take the derivative of numerator and denominator separately. So e raised to x derivative e raised to x minus 0 upon derivative of 1 upon 1 plus x is minus 1 upon 1 plus x whole square and derivative of 1 is 0. So simplified, so I am getting limit x tends to 0 e raised to x upon minus 1 upon 1 plus x whole square. Now put x equal to 0, so I am getting e raised to 0 is 1. It means that it is not any indeterminate form. If numerator or denominator is non-zero, it means that it is not indeterminate form. So I am getting e raised to 0. So x equal to 0 you put, so minus 1 upon 1 plus 0 whole square. Directly also you can write. So I am getting here 1 upon and this value is minus 1. So what is value of limit? That is minus 1, which is your required answer. Now consider next example. Evaluate limit x tends to 0 log of sin 2x upon log of sin x. So solution for this, consider given limit as L. So limit x tends to 0 log of sin 2x upon log of sin x. Now as x tends to 0, sin 0 is 0 and log 0 is infinity, and that is why I am getting here infinity by infinity form. And we know when 0 by 0 or infinity by infinity indeterminate form, we can use L'Hospital's rule, and therefore by L'Hospital's rule. So what is that? L equal to limit, what is L'Hospital's rule? Take the derivative of numerator and denominator separately. So what is log of sine 2x derivative? It is 1 upon sine 2x into cos 2x into 2 upon log of sine x derivative 1 upon sine x into cos x, and that is equal to limit x tends to 0. So I am getting here 2 into cos 2x upon sine 2x. It is a cot 2x upon cos by sine, it is a cot. As we know, for simplicity, I can consider 1 by cot is a tan x and cot 2x it is 1 by tan 2x, and that is why this 2 as it is, and here I can write it is a tan x upon tan 2x. Here tan 0 equal to 0. So again 0 by 0 form, or you can use here L'Hospital's rule. So by L'Hospital's rule, again take the derivative of numerator and denominator and put the limit. Instead of that, one can use direct or standard result also if you know. Otherwise, you have the other option, use indeterminate form, L'Hospital's rule. So what is that? See the adjustment now. Note this adjustment. That is equal to limit x tends to 0 tan x by x into 2x upon tan 2x. So I can consider this is one thing and this is the another thing. So x and x multiply and divide. These two already there, and that is why, as we know, limit x tends to 0 tan x by x equal to 1. Similarly, theta upon tan 2 theta as limit theta tends to 0, that is also 1, and therefore I am getting here 1 into 1. So what is the value of this limit? It is a 1, which is your required answer. Note that if you don't know this result, you can use your L'Hospital's rule, because here I am getting 0 by 0 and I am getting here the derivative of numerator is a sec square x upon derivative of denominator is a 2 sec square 2x. So 2 cancel, and sec 0 it is a 1 by 1, again you will get 1. So that is the required answer.